Well, good evening, everyone, and welcome to Environmental Coffee House. As usual, I haven't changed. I am Sandy Schoelles, and this is Jennifer Hynes, and we have a very busy show. We are revisiting methane and permafrost and Greenland. So take it away, Jen. Give everybody the synopsis, and I'll say hello to the whole chat in a little bit.
Okay, great. Hello, everyone. So great to see you tonight. So, listen, tonight is all about methane. And we've got quite a good show. Sandy's put together a fabulous presentation, comme d'habitude. And here we go. We're going to be first up with CNN. Greenland's northern glaciers are in trouble, threatening dramatic sea level rise. Study shows.
Ooh.
Ooh, ooh, ooh.
Mm-hmm.
And there is a link mentioned in that particular article, and it is the background nature communication story that is rapid disintegration and weakening of ice shelves in North Greenland. So this is all about the North Greenland ice sheets and ice shelves and what is happening to them. And speaking
Mm-hmm.
of what is happening, we have an article from Eliot Jacobson. What?
Yahoo! We got Elliot.
Yay,
I got it.
Eliot.
Yay,
Yay,
Elliot.
Eliot. Yay, Eliot.
I just
What the
told
fuck
him.
happened to the methane monster? WTF happened to the methane monster? Yeah,
Yeah,
right. Yeah. Eliot's so funny, right?
we love
Then
Elliot.
IFL Science, surging methane suggests Earth is brewing an ice age termination event.
Oh boy, that
Whoa.
sounds scary, doesn't it?
It does. Methane levels are currently sky
Termination.
high, just like they were during Earth's
Ooh.
previous termination
Oh,
events.
that's a scary one.
Then we've got kind of a pretty sort of photographic retrospective from Wired, the Arctic's permafrost obsessed methane detectives. And then we're going to take a quick look at Tyler Jones, who's an assistant research professor at CU, Colorado
Boulder.
University, University of Colorado,
Yeah.
in Boulder.
Boulder.
Boulder. I don't know why
Boulder.
everything comes together in Boulder. It's so weird, right?
Because Boulder is the center of the universe. It is.
Yeah.
The
Well, you
climate
can tell that to
universe.
people in Boulder.
Boulder studies methane. All right,
There
guys,
you go.
let's get started.
Right. Then we've got something from paleoclimate.substack.com, Polar Ice Cores Part 3, Variations in Greenhouse Gases.
And that one is showing his website, his Substack. So we probably won't read it, but we're going to show everybody so that they can have. There's a new paleoclimatologist on board.
Oh.
Yeah.
And then we've got something from phys.org. Near surface permafrost could be nearly gone by 2100, scientists conclude.
Yeah.
And then from NPR, judge rules Willow oil project in Alaska's Arctic can proceed. So it was off for a while, but now it is back on,
Mm-hmm.
unfortunately. And this from Malachi.mp. I'm not really sure what MP is. How we know that global warming is accelerating and that the goal of the Paris Agreement is dead. That's
James
not very.
Hansen came out today.
Oh, really?
And yeah, it is. It is. We're
Oh,
going
yes,
to
James
talk
Hansen.
about it.
That's right.
Yep, we'll be the first, but I'm sure
Oh,
that we'll
my.
follow up with Paul Beckwith because I'm sure
Right.
he will cover this and he'll cover it well because Paul is
Oh,
our
yes, he
buddy.
will.
Uh huh.
He is.
All right,
And that's
so
it. That's where we're
that's
going tonight, guys.
what we're gonna do. Okay, then let me pull up our articles and we are going to get going. Different mode, but first, I have a presentation. Don't I always? Yes. Okay. Really quick. Thank you, Kim, for moderating. And Keith Boyd is here from New Zealand. And that was really, really cool to see you, Keith. So that's exciting. And everybody, Obsolete Optics and Scott for moderating. And who else is here? All right. We got all our moderators. Jean's not here tonight. So ready to go? Here we go. Some of you may have seen this. I'm using it again.
Concern about air quality usually centers on pollution, as in the ironic observation, if you can't see it, don't breathe it. Increased reliance on coal is a crucial part of the Carter administration energy program, but the Senate Energy and Natural Resources Committee heard warnings today that a coal-burning society may be making things hot for itself. Nelson Benton reports.
The so-called greenhouse effect is created by carbon dioxide, a colorless, odorless gas. In small concentrations, it helps to sustain almost all life on Earth. The relatively small amounts of carbon dioxide in the Earth's atmosphere filter the warming rays of the sun to the Earth's surface. But like a greenhouse, carbon dioxide also prevents heat given off by the Earth from escaping into space. Researchers say increasingly large amounts of CO2 are accumulating in the atmosphere. They fear the Earth will gradually become warmer, causing as yet uncertain but possibly disruptive changes in the Earth's climate 50 to 70 years from now. Fossil fuels, when burned, release carbon dioxide into the atmosphere. Coal, the worst culprit, oil and natural gas to lesser degrees. Scientists and a few politicians are beginning to worry that global energy planning does not take the greenhouse effect seriously.
Okay. They didn't take the greenhouse effect seriously, but I played this clip over again. There's some of you that are new with us and haven't seen it. I had folded it into a different video, but it just shows you, this has been talked about, and that was how they showed the greenhouse effect. And Walter Cronkite, yeah, Scott, Scott didn't know Walter Cronkite was still alive. We have to bring levity, sorry. It's such a heavy subject. But next, here we go. I want everyone to pay attention and listen.
I'd like to talk to you a little bit about my own story before we get started and let you understand why it is that I'm so passionate and so committed to this story that we're going to unfold for you today. It takes some courage to understand the story because we have to open ourselves to grief. So the question is, do we have the courage to hold the grief that comes with the end of a story? It's my belief that this is the end of a story. I came to this knowledge about global warming on an emotional level about 2 years ago. I was coming back from England and I was flying to Denver. And it was a direct flight, and our flight, for some reason, was directed on a more northerly path than it had been planned. And as it turned out, we flew directly over Greenland. Now, I had flown over Greenland several times in the 60s and the 70s as a child because I had grown up overseas. And I knew about Greenland. I knew it was a massive white expanse, unbroken, clean, just this unending sheet of ice. So when I flew over Greenland in early September of 2012, I was not prepared for what I saw. The first thing that I saw were thousands and thousands of icebergs. As we approached the island from England towards, flying west, there were thousands upon thousands upon thousands of icebergs in the water. At first I thought the water was very choppy and very rough, but then I soon realized that these were actually icebergs and they had been discharged from the island itself. I didn't see the island yet. Then we got closer and I saw the island, and it was a towering mass of gray stone mountains rising up sharply. And the ice cover was very, very thin and very dirty and runny, and the whole thing, and keep in mind too, this was the southern half of the island, but it looked like a melted ice cream cone sundae, and it was very, very sad. A lot of very dark, very condensed ice. And I had a visceral awakening at that moment because the comparison of going over Greenland 30 and 40 years earlier and now was stark, was shocking. And I realized that global warming is very, very much underway. So this is, my effort to tell you about this situation today.
Thank you, Jennifer.
Wow, that was a blast from the past. That was the methane monster 9 years ago.
Yes. and there'll be links. Quite a cadre of work our Jennifer has done. Yes.
You believe in climate change.
It's not a belief. It's not about a belief.
Right.
When it's objectively true, you don't have to believe it. It just is true.
Yeah. When it's really hot, I believe in it. If it's like a hot day, I'm like, damn, they're right. They right about this shit. I'll tell you that, bro.
Okay, there's our little levity. And as we move on, this is nice. It also is a little bit older because nothing's changed. That was beautiful, wasn't it, Jim McHenry? Jennifer's account.
Have you noticed any changes since
Well, there's been a lot of changes. We get late freeze up in the fall, like we used to travel, start driving dogs over the ice in the middle of September. In October, we used to build igloos.
Every year it's different. Like it can get warm, or it can get very cold. The water sea level has risen a little bit ever since I was 13. Like I looked at the ocean sometimes when I was 13, 14, 15 to 19. Water level has been getting higher and higher.
Well, I've noticed that there's less beach to walk on, and there's a lot of permafrost melting. You can see here, there's a lot of erosion happening.
At that time, the shoreline was way out and I had no problem driving the vehicle over and behind my house. But now, in 2015, 3 storms took most of it, close to about 20 feet off of it. And it's just been getting worse and worse ever since.
Those are things that I go to bed worrying about, whether or not there are going to be char in 40 or 50 years in Nunatsiavut, or what's going to happen to our caribou. And these are all linked to climate change, and so that's what really drives me to work on behalf of this issue.
I just think that kids should be very aware of climate change, and I think that we should all take it serious because we are the next generation and we could make a change in the world. People may doubt us, but it's what we have the power to do anything. Like what my dad Eddie always said, have determination and effort and nothing will be impossible. So yeah, just be aware and prepared.
I like your words, Ariel.
Thank you.
I liked her words too. That was really very lovely, wasn't it? It was made for COP 2006, and of course it's going on. I mean, 2000 and when? 16, or COP number. I don't know what number it was, 25, whatever. It was made for a different one. Now we're on 28. You know, marching on in the Council of Parties. So what this is, it was from an article, and I don't think I have the article, but it just shows the terrestrial permafrost subsea and permafrost domain. Now you see in these pictures how the permafrost looks. There's lots of it. It's thick. Then this is a scenario. So I made another slide to show you that, because it was interesting to me, the extent and example futures of permafrost domain. Definition of the domain includes marine and terrestrial regions, substantially substantially affected by perennial frozen material, including oceans and seas above 50 degrees north, subsea permafrost on the continental shelves, Arctic tundra, boreal forest, and alpine permafrost. The figure shows the potential permafrost futures for the scenarios: B, a rapid decarbonization scenario, and C, a continual fossil energy scenario. Panel B depicts 1, resilient biological communities in marine, coastal, and terrestrial environments. Number 2, persistence of sea ice, especially crucial multi-year and land fast ice, maintenance of net greenhouse gas uptake in the permafrost domain. So let me go back to this and see, that's what you're seeing. All these numbers here, these are what is being described to you on the other page. So I found that interesting, and because they in one graphic like this, they're depicting expansion of fossil fuel extraction and navigation, disruption of food webs. They're showing you possibilities, potentials. Do you guys see it? I hope you do. But see, this is if we do nothing. Down on the bottom, we do nothing. We stay. It's gone, Jennifer.
Yeah, no, it's getting thinner. It's melting. I'm melting.
I don't know if I
Except
have
the proper term is thawing for
Yes,
permafrost.
it is. It's the permafrost thaws and the ice melts. So
That's right.
this is another graphic I thought you might want to talk about a little bit.
Yeah, pretty easy to see where the ice wedge is, that big white thing, and the active layer, that's what's melting. The layer below the active layer, that's what's getting ready to melt or thaw. And that's that.
Yep.
Thaw.
Thaw. Okay, there's the singing choice for tonight. Yeah, and here we go, everybody. Sit back, and we have another foray into something quite lovely.
My name is Jennifer Hynes, and I'm a climate change researcher and an environmental activist. I'm not a climate scientist, but I am a climate generalist, and I look at all aspects of the climactic in environmental systems. I really feel a deep sense of urgency about global warming and climate change at this time, and I have a real passion for data and a passion for trend analysis. And I've utilized that passion to galvanize me to create this. This is our Earth, our beautiful, lovely, life-giving, glorious Earth. So beautiful, so sentient, so life-affirming and giving us life that is so unlikely in the vacuum of space. We have a crucible of life on this planet, and it has a molten core of iron, and it's spinning around a ball of fire in the vacuum of space. Life is unlikely. And look at the Earth's biosphere, so beautiful and so thin. It's thinner than an eggshell in comparison, but it sustains our existence, but it's in trouble and it's dying. We face a time of environmental destruction that is unprecedented in human history. In fact, we are taking this moment to come together and look at what's actually going on in the Arctic. We're going to take a look at the changes in the Arctic and how they're directly affecting every other ecosystem on Earth in a domino sort of effect. We're going to be taking a look especially at the self-reinforcing runaway feedbacks that are actively working together to speed up the planetary unraveling that is currently underway. This is not something that might happen in the future. Many runaway feedback processes are in play and have already fired. And it's important to understand how the Arctic is changing and how these changes in the Arctic will directly affect our lives here on Earth. Do we really know the extent of change that has been happening in the Arctic? As goes the Arctic, so goes the world. That's what I always say. In order to make any way forward as a civilization, we really need to come to grips and to educate ourselves about the current situation of what is actually happening to our beautiful Earth. It's probably not such a matter of willful blindness that makes us so easily accept the new present as something to be adapted to. Perhaps climate change information is not easily understandable or widely available. Perhaps we've become so disconnected from our Mother Earth that we have forgotten who she is, and it is she that gives us life and breath.
Oh my gosh.
My
That was
goodness.
so beautiful. And it was your intro. You were going to be doing a big presentation that day. And this was your intro.
Yeah.
Remember? Yeah.
Yeah. That was Methane Monster too. God, that thing was like 2 hours and 45 minutes of pure doom.
Yeah, well, but it was the words, what you said. It meant a lot to me, and I've heard it quite a few times, but every time I use it for something and listen again, it just makes me feel knowledgeable, good, grateful for you in my life.
I'm grateful for you.
Yeah, there you go. It's a good thing. It's a really good thing. But now we're moving on. Peter Dines was showing this in Twitter, so I thought I would bring it up. I like him. He likes us. October's heat was unprecedented, and November continues the trend, confirming the hottest 12 months on record. The existential threat to civilization is already here. Urgent mitigation measures are required. And there are a lot of people talking about those things because we know that things are going to happen no matter what. It's just very disconcerting that it's this late of an hour. I mean, we started out with Walter, and, here we are. And there's the methane.
Yeah.
This will be
still going up.
Yeah, but see
Still
how it
going
goes
up.
down a little bit? It's going to all be explained in Eliot's article. Okay?
All right.
All right. So I hope everybody's enjoying the show. And one more. And then we move on.
In the Arctic and the circumpolar north, we are experiencing the climate crisis at up to 4 times the rate as the rest of the globe, a phenomena called Arctic amplification. That means that our homes, our ancestral homelands, are becoming inhospitable to our communities as increasing winter storms are buffering our coastlines, and our sea ice is no longer forming in the same ways to protect our communities from such weather. It also means that melting permafrost and increased erosion is preventing our communities from finding solid ground to build on and to subsist on, as well as disturbing our traditional life ways and subsistence practices.
It's been a really turbulent last year and a half. This has been a time where we have been reminded of how vulnerable we are. But we have also been reminded of how fast things can change and be turned completely upside down. In some parts of the world, we have experienced what it is like to truly treat an emergency like an emergency and to change social norms. But while all this has happened, of course the climate crisis hasn't disappeared. And we have not disappeared. The concentration of CO2 in the atmosphere hasn't been this high for at least 3 million years. It is clearer than ever that no political party is doing close to enough. But it's even worse than that. Not even their proposed commitments are close to being aligned with what would be needed to fulfill the Paris Agreement. If we want to ensure a safe present and future on planet Earth, we need to be active democratic citizens and go out on the streets like we are doing today. We must keep going into the streets, and we must keep demanding our leaders to take real climate action. We must never give up. There's no going back now. But we can still turn this around. people are ready for change. We want change. We demand change. And we are the change.
There are less than 22,000 Atlantic walruses left in the world, and their numbers almost completely crashed in the last century due to hunting. It wasn't until legislation protected them that their numbers started to recover. But now they've got the additional pressures of climate change. So Arctic species, such as walruses, polar bears, and many species of seals, rely on sea ice as their habitat. So as sea ice is disappearing due to climate change, they're losing habitat. So we can expect to see more and more of those Arctic species becoming vagrants and becoming displaced from their native habitats and having to explore new range. So we should definitely make sure to keep these animals safe when they seek refuge on our shores, and do whatever we can to avoid harassing or stressing them.
Wow, great presentation, Sandy. Thank you so much. You're muted.
Sorry, that one, I have a lot of information, a lot of stuff I did, and that one's from 2021, one of our shows that we did together, Jen. Uh-huh.
Amazing.
Yeah.
Yeah, I recognize some of that. Yeah.
I have a
Great.
cadre of stuff I've done, and sometimes I feel like, why not share it again?
Absolutely.
Yep.
Yeah.
All right. Well, now we are going to go down and we're going to bring up our reading. The reading portion of the show, we are going to educate and learn together, actually. So I think you might want to take this one, and then we
Right.
will. And I do have a little Twitter up after you read it to show you. And so take it away, Jennifer.
Right, guys. So this up from CNN, this just published November 7th. So pretty much hot off the press.
Yeah.
Greenland's northern glaciers are in trouble, threatening dramatic sea level rise. Study shows. At the top of the world, northern Greenland's huge glaciers, long thought to be relatively stable, are in trouble, new study shows. As the oceans warm, Greenland's last remaining ice shelves are rapidly weakening, destabilizing the nearby glaciers and threatening potentially dramatic consequences for sea level rise, according to a study published in Tuesday in Nature Communications. Ice shelves are tons of floating ice that jut out over the ocean and act as dams that hold back glaciers on land and slow ice loss. When they melt and weaken, more of the land-based ice is able to slide into the ocean, adding to sea level rise. Scientists analyzed 8 ice shelves buttressing glaciers in northern Greenland, which together hold enough ice to raise sea levels by 2.1 meters, nearly 7 feet, should they break down and melt completely. These glaciers are among the most important ice sheets, Roman Miller, a glaciologist at Grenoble Alpes University in France, and an author of the study, told CNN, they are the largest glaciers in Greenland. While glaciers in other parts of Greenland started to lose mass in the 1980s and the 1990s, he said, so far, in northern Greenland, they've remained relatively stable, But this appears no longer to be the case. Millen and his co-authors used thousands of satellite images along with climate models and measurements from the field to better understand the drivers for and timing of historical and current changes to the ice shelves. They found a substantial and widespread increase in ice shelf losses since 1978. Ice shelves supporting the northern Greenland glaciers have lost more than 35% of their total volume, according to the study. Found that since the early 2000s, 3 have collapsed completely, and the remaining 5 are melting and destabilizing nearby glaciers. We can see the ice shelves are weakening. And that's new key information that we didn't know because we thought this part of Greenland was really stable.
Yeah.
Ice loss came from a mixture of factors, the study found, including increased calving, which is chunks of ice breaking off to form icebergs, and surface melting. But the predominant driver was basal melting, where warm ocean currents melt the ice from beneath. Between 2000 and 2020, widespread increase in the rate of basal melting closely followed a rise of ocean temperature, the study found. Scientists noted a direct impact on glaciers. As ice shelves melt, the grounding lines, the point at which the glacier stops touching the ground and starts to float, are retreating. These natural boundaries are really the key parameter that indicates that glacier stability. As the grounding line retreats, the icebergs discharge into the ocean and also start to increase. If the oceans continue to warm, it could permanently weaken the ice shelves. And in a certain time scale, they could even collapse, which could have significant consequences on the contribution of Greenland ice sheet to the sea level rise. The region also plays a large role. Between 2006 and 2018, the melting of Greenland's ice sheet contributed to more than 17% of observed sea level rise.
Wow.
Right. It's not possible to give timescales for when such collapse could happen, but changes have happened fast since the early 2000s. After the collapse of the Zachariah-Assam Glacier ice shelf in 2003, the ice discharge into the ocean doubled. Millen said when he visited the glacier in 2016 and 17, the changes were alarming. He described it as a chaos of tabular icebergs. Future of the glaciers will depend heavily on what the world does to reduce planet heating pollution. The report calls for continued monitoring to better assess how ice shelves will respond to climate change and in particular to build on the study's finding about complex process of basal melting and the potential impacts on sea level rise. Quote, this will ultimately provide insight into the future of these glaciers as well as the fate of larger ice shelves in Antarctica. A recent study in Antarctica found that the rapid melting of the continent's ice shelves may now be unavoidable due to the melting from below. Sophie Nikiowski, an ice sheet expert in geology department of University of Buffalo.
Yeah, so finally we get to talk about me.
Yeah.
Mine, yeah.
Buffalo.
The wiki, yeah. Cool.
Who was not involved in the research, said the study's findings are significant because of the insight they provide into the sources and triggers of changes to Greenland's ice sheet. What is new in the long-term record and holistic view of ice shelf evolution, we knew that ice shelf basal melting is related to ocean temperature, but what is neat about the study is it gives a better idea about the timing and magnitude of the change. The study also adds to an overall understanding of how polar regions are responding to human-induced climate crisis. The poles were once seen as fairly boring, but since scientists began to observe them with satellites around 4 decades ago, it has become clear that these are dynamic, very fragile regions. As the planet continues to heat up, we should be concerned by how fast the changes are happening, but we should not
be surprised or astounded or, oh my God, I'm taken aback.
Or shocked. Or
Shocked.
shocked, I tell you,
Right?
shocked.
Jeff Baradelli, our favorite climate weatherman. Rapid disintegration and weakening of ice shelves in North Greenland. Here we show that since 1978, ice shelves in North Greenland have lost more than 35% of their total volume, 3 of them collapsing. And he used the same graphic from the article that I just did. So I was, going back and forth on that. It's right here. It was pretty graphic, showing the ice shelves in the changes and the basal melt, the calving, the green, the dark green, all the calving. Look at that.
Yeah. Look at, that's the entire northern part of Greenland. See that green map? No, down.
All right.
That right there, there.
Yeah,
that
we
green
go.
map, that shows the entire northern interconnected glacial region of northern Greenland, and it's all melting into the sea.
It's wild. It's just wild. But rapid disintegration and weakening of ice shelves. And we will move on. We are done with Jeff, and we are done with this. Now we're going to move on to Eliot. Eliot Jacobson, Dr. Eliot Jacobson, Professor Eliot Jacobson, has a climate casino. I think that's the name of his blog. And his newest was What the F Happened to the Methane Monster? And, well, Jennifer, can you give us just a little background on you and the methane monster and your relationship with that monster?
Oh, did I have a relationship? I thought I was running for my life.
Yeah.
Yes.
Terrible.
Oh, yeah. I mean, it was something that really gripped my attention for a long time. And finally, I got kind of tricked into creating the methane monster, and the rest is history. But yeah, I mean, the methane monster hasn't gone away. And the reason Eliot is writing this article is because it's sort of like not paid as much attention to right now in the news.
Except for us.
But, yeah,
Except
that's
for you
right.
and me, nerdos.
That's right.
And Eliot. All right, so I'm going to start it because Eliot does really well with this. He puts links in to go back to a different article to reference it. So we're gonna learn about stuff tonight, guys. Trust us. 2 years ago, methane was the rising star on the hit list of doomer messaging, and it was easy. The methane monster had so many different heads to choose from. From natural sources, we had permafrost methane, East Siberian Arctic shelf ESAS methane, methane bubbling up from the lake and ocean bottoms, and from an increase in termites.
Wow.
I bet you didn't know that out there, huh? From anthropogenic sources, we had methane from pipelines, fracking, animal agriculture, rice farming, landfills, LNG leakage, and more. Times were good for the methane-centric doomer. And there was even a Nova documentary, and that documentary got 11 million views.
Oh, wow.
Yeah, I'm not going to go to that, but that, yeah. So, and then about a year ago, except of course for Jennifer and I and Environmental Coffee House, it stopped. The media moved on from methane to the next big shiny climate change disaster. And there's been a long list to choose from. Antarctic sea ice extent, global 2-meter temperatures, sea ice temperatures, Thwaites glacier fires, cyclones, floods, heat waves, droughts, and poof, no one is talking about methane anymore. Imagine that. So he said, before you go on, he's been advised by a reader that you should read his other article, Is Methane Catastrophe Happening Right Now? Which I can reference it, but I'm not going to do that at the moment because I know where I want to reference it. So here we go. Methane is a greenhouse gas that is responsible for about 1/3 of the current rise in global temperatures from 1850 to 1900 IPCC baseline. Unlike CO2, which can persist in the atmosphere for millennia, methane tends to break down much faster. Depending on local atmospheric conditions, the over-under for a lifetime of a methane molecule is about 110 months. Now remember, his page, his website is called Climate Casino.
Mm-hmm.
So the over-under, all right? Because methane breaks down so much faster than CO2, curbing anthropogenic methane was viewed as a quick fix to buy time to do something meaningful about CO2 without breaching the Paris limit. This strategy led to the so-called Glasgow Pledge, written in 2021 at the very end of COP26. So here's the summary. 103 countries, including 15 major emitters, signed up to the Global Methane Pledge, which aims to limit methane emissions by 30% by 2030 compared to 2020 levels. So at the most basic level of data, total atmospheric methane keeps rising. The graph from NOAA shows methane from July 83 through June 2023. Now that's 40 years, and in that time, methane has risen about 300 parts per billion, and in the last 12 months alone, methane rose from 1905.19 parts per billion to 1917 0.11 parts per billion. There is little doubt that methane will exceed 1930 parts per billion by the end of the current 12-month cycle. Well, this is it. Now, we had already seen another one earlier in the presentation, that where it goes down, and we're going to learn about why that happens. The next level of analysis is to see how fast methane is growing. The bar graph from NOAA shows the annual global increase of methane. Unfortunately, the graph is only updated once a year, usually in April, to account for data from the previous calendar year. See the spike up here? And then a little bit pretty low down there. Although one of the most crude metrics available, it seems clear that the peak reached in 2021 was part of the reason for the global methane media and doomer freakout. Methane appeared to be skyrocketing. Remember that, Jennifer?
Mm-hmm. Yeah.
And then we had COP26 and the Glasgow Pledge. And sure enough, a year later, the data showed the start of the decline in the rate of increased methane. So, should we be freaking out? Or has methane monster been decapitated? To find out, I'm going to redo NOAA analyses, taking into account the atmospheric half-life of methane and resolving this on a monthly basis, which I thought was way cool. Thank you, Eliot. I want to take a moment to do a bit of simple math to illustrate the focus of my analysis. Suppose methane was 1905.19 parts per billion in June 22 and 1917 parts per billion in June 23. Well, what really happened? How much methane was really added to the atmosphere? If you're like NOAA, you just subtract the two numbers and come up with 1192. So you see the difference. Okay. Very simple, very easy. And then you say that methane grew by 11.92 parts per billion over the last year, and you just plot that point. Well, that's wrong. And the reason it's wrong is the short atmospheric lifetime of methane. So if methane has an average lifetime of 110 months, then after 12 months, we should expect the original amount of the 1905-19 parts per billion to be reduced by some amount of natural decay. To put it simply, if you know the amount of methane in a given month, call it old methane, then the amount of methane that will still be present the following month is approximately given by, there's the new methane equals old methane times 1/2 of 1/110th. Okay? If we use the same formula plug in the numbers, starting at 1905.19 parts per billion in June 2022, then the methane is reduced by a natural decay to 1766.45 natural by June 23. So the only way we could get an actual reading of the 1917.11 in June 23 is for the amount of methane added to the atmosphere over these 12 months to be the 19.17, right, minus the 1766 that he factors in. So the difference is 150. It's different.
Yeah.
Do you have something?
Because he has to count the degradation rate.
Right.
So that's what he's got in there.
Right.
Yeah.
He's being more specific.
Mm-hmm.
And so he redid the NOAA chart using the fact that atmospheric methane is constantly delaying. And we've talked about this, Jen, in our shows before. I also use some smoothing to account for the natural yearly cycle. And I use their full monthly data, not just yearly numbers. Putting that together, here is my improved one. You want to talk about this one, Jen?
Well, you can kind of see here where it was really kind of in the quote plateau area. And this is the growth of methane year over year. This is methane change. And in 1998, there was a super El Nino. And at that time, it appeared, and it was kind of an optical illusion because there had been so much heating in the super El Nino of 98 that global warming had just kind of ceased. But really what that was is just that in-between period, and all that heat had gotten added to the atmosphere. But that also affected the methane emissions, and you can see that right here. So the orange line there is the Glasgow Pledge, and 30% by 2030. Do you think we'll get there? Let's find out what the math says. Methane growth peaked in August 2022 at an annual rate of 160 parts per billion. Since that time, the rate of methane growth has been slowing down, and in June 2023, it had fallen to an annualized growth rate of 157 parts per billion. The rate of methane growth has been slowing down for the last 10 months. Let's be clear here. The amount of methane in the atmosphere is continuing to rise. It's the growth rate and the rate of increase of methane that's decreasing. Because of this, eventually something interesting has to happen. And here's the fun bit of math, for me anyway. He says,
it's fun.
We can project this all into the future. Oh, joy, oh, rapture. If the current slowdown trend continues, then methane will peak at 1,966 parts per billion in November of 2027. Atmospheric methane will then gradually start to fall. We will reach the Glasgow Pledge of reducing anthropogenic methane by 30% in September of 2032. By December of 2034, methane will once again be under 1,900 parts per billion. This is a very nerdy thing that he's doing.
I love it.
Yeah.
I love it.
The following graph illustrates this prediction, and you can see that he's showing that methane falls off and it actually decreases. But that doesn't seem right to me.
No.
Well, fans,
Yeah.
that's more than enough fairy dust and mathemagic. Now for some reality. The first big question is, if the slowdown of methane growth is due to proactive climate actions that will eventually get us to the Glasgow Pledge, or if it's a consequence of something else, the answer is it's something else.
Yeah.
The formula explains it all. The formula is longer atmospheric lifetime for methane equals more methane.
Yeah.
It's worth remembering that if we had a lockdown just before that huge 2021-2022 jump, The massive rise in new methane may have been an artifact of the pandemic's impact on air travel, which led indirectly to a longer atmospheric lifetime for methane and the appearance of significant reduction when there was none. So he is citing that there is an article here called COVID-19 Lockdown Emission Reductions Have the Potential to Explain Over Half of the Coincident Increase in Global Atmospheric Methane. Interesting.
Yeah.
Likewise, the tropical fires in Brazil, which have declined with Brazil's new government, may have led to a depleting hydroxyl radicals, the primary scrubber of atmospheric methane. So get this, if there's a depletion of hydroxyl radicals which scrub the methane, then the methane persists in the atmosphere. Less hydroxyl equals longer atmospheric lifetime equals more methane. Methane is much more sensitive to global heating than previously thought. I explore other potential reasons for the 2021-2022 peak having to do with a longer atmospheric lifetime for methane. The second big question is if the East Siberian Arctic shelf, permafrost, or some other natural source of methane is going to light off, instigating a multi-gigaton release that will make all human actions inconsequential. Short answer, yes.
Yes. The methane
bomb. It's gonna happen. Oh, yay. It turns out there's new information coming out all the time. For example, and he cites these two articles called Arctic's Melting Glaciers Reveal Hidden Methane Time Bomb. We might have even covered that, Sandy.
I think we did. Yeah, we did.
Yeah. And mapping methane emissions from rivers around the globe reveals surprising sources. So those are two articles he's citing. The third big question is what impact the current ENSO cycle will have on methane.
Yep.
And you guessed it, warmer weather during El Nino helps create more equatorial fires, which creates more carbon monoxide, which cannibalizes hydroxyl radicals, which increases the atmospheric lifetime of methane, which increases the total amount of methane. It's all connected. Interesting. So another article he's citing here, impact of El Nino Southern Oscillation on the interannual variability of methane and tropospheric ozone. My God.
The troposphere, darling.
The troposphere.
Sounds like
So
a dance.
just a little bit of reading of practically any sensible article will show you that the peak growth of methane reached in 2021-2022 was an artifact of the moment, and it's coming back. So here's my over-under. Anthropogenic methane won't slow down until global civilization slows down.
We slow down.
And little things like the feedback loops from unattended fires and huge decline in air travel could negate that slowdown by lengthening methane's lifetime. So there's a wash. Meanwhile, we have more than enough natural methane bombs with their fuses lit, windows of opportunity welded shut, and canaries in the coal mine dead and buried. In other words, methane bombs will go off. My over-under? There's none. It's all over at this point.
Wow.
I know why the media stopped its coverage of methane. It's not sexy. It's not bloody. It's not funny. And it's hopeless. Meanwhile, there are just too many other stories that sell better. From politics to wars to religion to social justice to celebrities to royals to sex scandals. The whole planet of humans is pretty fucked up right now.
And I guess we will take the planet of humans that are fucked up, not us, of course, and we will give them the environmental coffee house flush of the day. Yeah. I thought that was really good. I enjoyed reading it and trying to figure out everything. And it was, thank you, Eliot. If you're watching, I don't know if you're watching, but thank you. And now, Jennifer, we're moving on because another big thing, and there are YouTube videos out there talking about this termination event. And we can tag team this one. It was from October, but I watched several videos, and this was I thought this was the most digestible of the articles. So the past 7, I think this is the research is right here. Oh, no, it isn't. I didn't pull it up. All right. The past 17 years have had some unusual rises in the levels of methane gas in Earth's atmosphere. And this surge might be a messenger for something bigger, according to new research. It's not certain what this methane increase means exactly, but scientists argue it's reminiscent of past termination events in Earth's climate system that have ended ice ages. Now, Jennifer, where does that fit in with what Eliot just wrote? That's what I kept, when I was reading this one, since I read it after Eliot, I was, trying to make it all fit together. I wonder if he's taken that step.
Well, Eliot says the methane bomb is going to go off. So this is a termination event. It is the termination of the current ice age that we are still in. Yes, we are in an ice age still. There's ice on Earth, and
right,
we are
of course,
kind of interglacial.
And we're watching it turn to permamush.
We are.
Yeah. So Earth's climate constantly swings between long and cold glacial periods, often called ice ages, where vast ice sheets cover northern Europe and Canada, and shorter interglacial periods of warmer temperatures. This happens on a giant timescale of thousands of years, much longer than a human lifespan. The end of these ice ages is known as glacial termination, an overhaul of Earth's ocean atmosphere system that marks the transition from a glacial to an interglacial period. This is another lengthy process which typically takes thousands of years. So currently we're in an interglacial stage of an ice age called the Quaternary Ice Age, which began around 2.5 billion years ago and continues today. However, there are hints that some kind of change could be brewing. Looking at Earth's methane levels, there are some indications that we might be in the early days of a termination-like pattern. Jen, you want to look at this and talk about this?
Well, here we have the global monthly mean of methane, CH4, and we know this very well. You can see the ebbs and flows on an annual scale. But what's most notable, guys, is if you look at the upper right and the further acceleration, the dots are getting further apart for each year because look at the angle, look at the declination of that last bit of the line over on the upper right-hand side. It is very steep. It is a lot different than the other lines, and it's getting steeper. So I think we're in the beginning of a termination event, and I think that's what it looks like.
Okay, well, it naturally exists in the atmosphere and it can act as a potent heat-trapping greenhouse gas. The majority of the gas has an anthropogenic source, namely fossil fuel use, farming, landfills, waste, but the remainder comes from natural sources, notably rotting vegetation in wetlands and thawing permafrost. Levels quickly climbed throughout the 20th century in the wake of the Industrial Revolution and fossil fuel combustion, but the increase plateaued towards the end of the century. So then around 2006, another rise in methane began, and we just saw that on the other graph, not purely related to fossil fuels. Now, much of these new emissions come from wetlands located near the equator. Bear in mind, though, this itself is a consequence of climate change creating warmer and wetter conditions that fuel decomposition in the wetlands. Sorry. In a new study, scientists looked at recent. I think they're right. In a new study, scientists at looked. Recent changes. Okay, they need a new
They
editor.
need a better proofwriter.
Yeah, they do. In
Yeah.
methane from 2006 to 2022 and compared it to patterns seen during previous glacial terminations. Their findings suggest that methane levels are currently behaving how they did at the start of these grand transitions from cold ice ages to warmer interglacial climates. So it remains possible that methane's current growth is within the range of Holocene variability, but it is also possible that methane's recent growth and isotopic shift may indicate a large-scale reorganization of the natural climate and biosphere that's underway, the study's authors say. And there are some good videos out there. I'm not going to play this one. I think it's too long. Jen, you want to do the little...
Yeah, absolutely. But guys, do watch this video. It's very interesting. It's 13 minutes, so we're not going to play it, but it's well done. I did watch the whole thing.
Yeah, me too.
Since we are already in a warm interglacial stage, it's not certain how this potential termination-like event could unfold. However, this does not mean that we are at the dawn of a new ice age. Together with better understood impacts of climate change, it's likely the Earth will be heading towards an even warmer climate, bringing sweeping changes to the Earth's natural systems. Methane is both a driver and a messenger of climate change. We don't know why it is now rising so rapidly, but the pattern of growth since late 2006 resembles how methane behaved during these great flips in Earth's climate in the distant past. Roman numerals 9 to 1 denote, I guess that must be on some graph.
That's
coming
Ewan
up.
Nisbet. We talked about him in August when we did our methane show.
Oh, Ewan Nisbet, the study in
this guy.
Okay, the professor of Earth Science at the Royal Holloway University in London. Okay.
Yeah, he's been on the talk show circuit, Jen.
Okay, Roman numerals 9 to 1 denote great climate transitions. There is no Roman numeral 0. But then any future termination scale transition will be different, a temperature step from our present interglacial climate to some new future that is warmer yet. Methane signal is still unclear, but the question remains, has the termination 0 begun? And my thought is yes.
Yeah, and
we
so
are
do a lot
in
of videos.
Termination 0.
Very interesting stuff. So here's the article. The Advancing Earth and Space Sciences. So guess what?
Okay.
Now we are moving on to permafrost. And we have a new person to introduce. And just let me get rid of that bullshit on the bottom. Ad on my Jennifer, my browser that's not supposed to have ads. All right. So the far north. Did you want to do this one?
Either way, you tell me. I'm good. If you want me to read, I'm
Read
good.
it.
I can do it.
Yeah.
Okay, guys, here we go. This is an article from Wired. Very, very pretty photographs here. The Arctic's permafrost-obsessed methane detectives. The far north is thawing, unleashing clouds of planet-heating gas. Scientists rely on an arsenal of tech to sniff out how nasty the problem is. And check out this little measuring thing inside its little cage. It's in a little net cage because it's in a golf course or something.
I know.
Yeah.
Pretty wild.
Covered in netting to deflect stray balls, these instruments gather methane data on the 7th hole of Midnight Sun's golf course. Permafrost is rapidly thawing across the far north, deforming fairways here and releasing the highly potent greenhouse gas, which leads to more warming. So this whole golf course is warping every year from methane.
And they're measuring it. Yep.
Oh my God, that's so wild. At the Midnight Sun Golf Course in Fairbanks, Alaska, they say you never get the same shot twice. That's because the Arctic is warming much faster than the rest of the planet. And as the underground permafrost thaws, it deforms the course's fairways. This express defrost unlocks ancient organic matter, a lot of it. The world's permafrost holds twice as much carbon as it currently is in the atmosphere. Microbes feed on that liberated matter and fart out plumes of methane, a gas that's 80 times more potent than carbon dioxide on a warming planet.
Was that my cue to look for the fart thing?
I don't know. I've never seen an article that was talking about farting out the methane like that. It's really wild. And as thawing permafrost releases more methane, it raises global temperatures, which thaws more permafrost, which releases more methane. It's a dreaded climate feedback, and scientists are using an array of tech to understand it better.
Like this one?
We know the future of the Arctic.
No, go ahead.
We know the future of the Arctic. We know the future of the Arctic is all about warming, says Tyler R. Jones. That's the guy that we're highlighting, a geochemist at the University of Colorado in Boulder.
Yay!
Boulder, yay, Boulder. To be prepared, we want to understand permafrost environments better, to model them better. We want to know what's possible. Fairways happen to be perfect locations for scientists to land their specifically designed drone. The aircraft, which carries instruments for sampling greenhouse gases, has a wingspan of 10 feet, but it lacks wheels, so the team has to belly land it. Wow. You can just make laps around a feature of interest and get a profile of a methane plume, Jones says. The golfers let us play through for a minute and land our drone, and then they hit their shots. Funny.
It is. Very interesting.
Nearby lurks a site of particular interest or dread, depending on how you look at it. Big Trail Lake is a product of a violent thermokarst event in which permafrost thaws so rapidly that the ground collapses. The resulting craters filled with water represent ideal conditions for microbes to produce methane. Indeed, Big Trail Lake may be one of the highest emitting lakes in Alaska, so the team collects methane data from a floating instrument tower there. It is probably one of the most sophisticated science experiments happening in the Arctic because of the different types of instruments, said Nicholas Hassan, a geophysicist at the University of Alaska Fairbanks. We're kind of like methane detectives. Whoa. And now we see all the pictures of them working. So interesting. Look at these guys. These are great pictures, aren't they?
They are. They really are. That's why I chose the article. I liked it.
Yeah.
This one's really cool.
Yeah.
The arch on the Kastner Glacier. The Arctic is losing ice, not just from its many glaciers, but from the permafrost. But the photography was cool. And there's the guy. Well, this is one of the guys. This is Chuck Smallwood, and they're taking ice core samples, and they're interested in characteristics of the permafrost itself. They study the microbes, and they can control the growing conditions, and he can understand how the microbes might produce methane as Alaska warms. So it's very cool. Ooh, look at that one, Jen.
Wow.
Yeah.
That must be one of those craters collapsing.
It's drained, and so they used it to take advantage of the situation and measure the methane of the thermokarst not filled with water. Right? Mm-hmm. They took advantage of it. I thought that was really cool. Now look at this. Do you want to be in there? They're underneath. They're underneath in their little mine. They're mining for permafrost, and that's an ice wedge. It's surrounded by a carbon-rich silt. As permafrost thaws, the ice melts into pools of water where methane-emitting microbes munch on the ancient plant material. Look at that. It almost looks, it just looks unreal. It just does.
It does.
What a place to work. Look at that. A permafrost mine.
Oh my God.
Yeah. Oh, it's over. Permafrost can vary significantly in its ratio. Okay, it was cool. How much methane from a warming landscape? And this one showed us what they do to get it. And actually, this is the guy, Tyler Jones, and we are introducing him from University of Colorado Institute of Arctic and Alpine Research. He is really interesting, and I think you guys should check him out because he has a blog, and it's called Paleoclimate, Paleoclimate with the slash there, and he writes about ice cores, and he has a whole cadre of information, collapse of civilization, uncharted territory, and he I think he writes with others. Well, actually, I don't know if he has his about quite written up, but this is who he is. So the new kid for us to follow. He studies he studies it through the lens of science and culture, and his research areas are Alaska, Greenland, and Antarctica. Jennifer, we should get him on.
I know we should. And he's been in Boulder forever. Every single one of his degrees is from Boulder, Colorado. He got his BS in Civil Engineering and Hydrology in 2006. He got his master's in Environmental Studies in 2010. He got his PhD in Biogeochemistry in 2015.
Yeah, interesting guy. And so he has a website also. And he is writing, and he likes sushi, ramen, and pho. And if he wasn't a scientist, he'd be a pottery maker down a long dirt road. That's really awesome. So we've got a new writer. We'll probably do another show, Jen, and
it would be great.
All right. So there's our new guy on the block, and we do have one more article on permafrost. We know it's going to be a long show. What do you think, Jen? Should we do it or go over it?
Well, are you talking about the paleoclimate?
This one, FISORG. Near surface permafrost could be nearly gone by 2100.
Oh,
and then,
we can blast through that. No
All
problem.
Right, let's blast because it's good. And then we have one to bring up the rear that's kind of going to piss people off, but we're going to do it. All right. Who wants to start?
I can start.
Take the over-under.
Okay, over-under. Here we go, guys, on FIS.org.
Yeah.
Just out September 19th, 2023. Near surface permafrost could be nearly gone by 2100, scientists conclude. Most of Earth's near surface permafrost could be gone by 2100, an international team of scientists has concluded after comparing current climate trends to the planet's climate 3 million years ago. The team found that the amount of near-surface permafrost could drop by 93% compared to the pre-industrial period of 1850 to 1900. That's under the most extreme warming scenario in the latest report to the Intergovernmental Panel on Climate Change. By 2100, Earth's near-surface permafrost within the upper 10 to 13 feet of soil may exist only in the eastern Siberian uplands, Canadian high Arctic archipelago, and the northernmost Greenland, just like it did in the mid-Pliocene warm period. The research published August 28th in Proceedings of National Academy of Sciences was led by Donglin Gua of the Chinese Academy of Scientists and Nanjing University of Information Science and Technology. Scientists in the United States, Russia, United Kingdom, Germany, Japan, Canada, Netherlands, France, Sweden collaborated in the research.
Everybody.
Quote, our study indicates dramatically smaller than present near-surface permafrost extent in the geological past under climate conditions analogous to those expected if global warming continues unabated. Professors Emeritus Vladimir Romanovsky of the University of Alaska Fairbanks at the Geophysical Institute is among the co-authors. Romanovsky is the leading scientist in permafrost research. The loss of this near-surface permafrost over the next 77 years will have widespread implications for human livelihoods and infrastructure, and for the global carbon cycle and the surface and subsurface hydrology, Romanovsky said. The research rings yet another alarm bell for what is happening on to Earth's climate. Simulations of the mid-Pliocene warm period climate are similar to the climate projection for the end of this century under the fossil fuel development pathway in the latest report of the IPCC. That pathway is the bleakest of the 5 presented for future society. Simulation for the mid-Pliocene warm period and projections of the permafrost extent in 2100 focus only on near-surface permafrost, which is less resistant to climate warming than deep permafrost makes sense. 10 computer models project the Earth will lose approximately 77% of its near-surface permafrost by 2100, relative to the 1995 to 2014 average under the IPCC's fossil fuel development pathway, if the surface air temperature increases by 13.5 degrees Fahrenheit. Interesting. The paper's authors choose to compare Earth's projected future to the mid-Pliocene warm period, which occurred approximately 3 million years ago, because it is the most recent period of sustained global warmth in the planet's geological history. Scientists had little direct information about the Northern Hemisphere permafrost during the mid-Pliocene warm period. To overcome that, they analyzed other factors such as vegetation composition and special soil features to reconstruct surface air temperature records. From that proxy evidence, they have projected permafrost extent of the mid-Pliocene warm period. Using computer modeling, they determined that global annual mean surface temperature at that time was between 5 and 6 Fahrenheit warmer than the pre-industrial period. It also showed that the temperature was almost 13 degrees, I think that's Fahrenheit, higher in the Arctic regions. Absence of permafrost is also inferred by marine fossil sediment records in northwestern Alaska, the paper states. The authors add that simulated winter and summer temperatures and precipitation variables, which arguably have the strongest impact on permafrost stability, have been shown to be similar for the mid-Pliocene and the years 2100 and 2200. The authors write that the study of the mid-Pliocene warm period permafrost distribution and associated climate drivers can improve our understanding of the extent, dynamics, and uncertainty of permafrost loss in a warmer future climate. Based on our findings, the future Northern Hemisphere near-surface permafrost appears bleak. The authors write, continued climate warming and related near-surface permafrost degradation may cause changes in ambient and environmental conditions that humans have not yet experienced, implying an imperative to further highlight the importance of permafrost degradation. And see, we bombed right through that.
Yeah,
and
that's good.
Is the permafrost is thawing. It is thawing.
Yeah.
And thawing
is.
fast.
We'll have all the stuff in the show notes.
Yeah.
We're gonna move over a little bit. No, we're gonna get you mad because I was mad because basically this story, it's why everything is happening. Judge rules Willow oil project in Alaska's Arctic can proceed. The massive Willow oil project on Alaska's North Slope can move forward, a federal judge in Anchorage ruled Thursday. The U.S. District Court Judge Sharon Gleason, and I looked her up. I looked at all her, the things that she's made decisions on, and I thought, well, she's been fair for most of it because I wanted to know. She rejected the claims of the environmental groups, who argued the government's decision to approve ConocoPhillips' project didn't adequately consider its contribution to climate change and potential harm to the region's threatened polar bears. The decision removes one of the last obstacles to the project, which would be the largest oil development on federal land in decades, and has become a flashpoint for climate activists. Environmental groups said they plan to appeal. The U.S. Department of Interior's decision to greenlight the project in the first place moved us in the opposite direction of our national climate goals in face of worsening climate crisis, said Eric Graff, an attorney with environmental group Earth Justice, in an emailed statement. The Willow project gained national attention earlier this year when a campaign calling on Biden administration to block the project went viral on TikTok. It was Stop Willow, Stop the Willow Project. It attracted hundreds of millions of viewers. Young people in particular took to social media to argue that a fossil fuel project this big would boost greenhouse gas emissions and is incompatible with President Biden's commitment to tackle climate change. Remember her name? Sharon Gleason. And all right, so anyway, ConocoPhillips has been trying to develop it for years. They got their approval in 2020 during the Trump administration, but at that time, Gleason tossed out the permits the next year, saying the government hadn't adequately assessed the project's potential environmental impacts. In March, after a new round of assessments, the Biden administration granted ConocoPhillips permission to go ahead with a slightly scaled back version of the Willow project, approving 3 drill sites. So in its legal briefs, the company cites what it sees as the benefits of the project, including an estimated $7.6 billion in revenue for the U.S. Treasury over the life of the project. Now, just listen to this one. 2,500 local jobs during construction. Remember that. ConocoPhillips also emphasized its efforts to limit the impact on the Arctic environment. The feat will be accomplished with a minimal footprint and a mere 3 drill sites and adherence to the most stringent environmental protection in the world. Now, a mere 3 drill sites, but are going to give 2,500 local jobs, right? I thought that was kind of, but there's, a lot of people feel different. Some Alaskan Native groups joined conservationists trying to block the project, citing concerns about the impact on caribou hunting and other subsistence activities central to the region's traditional culture. But the state's largest Alaska Native associations and major for-profit Native corporations have endorsed the project. So have most local and regional governments on Alaska's North Slope, which represent mostly Inuit Alaska Native communities. Local governments would reap billions of dollars from taxes and revenue sharing if the project's built. Money local officials say is needed to maintain infrastructure and social services in a region where jobs are scarce and communities are already coping with the disruptions of climate change, including thawing permafrost and shrinking sea ice. So we need to drill more. We need to send it out, pollute more. But they're already feeling all the effects. Just let's send the effects somewhere else. Nagruk Hartarek leads the Voice of Arctic did I say it wrong? Inupiat, a pro-development group. He says he's confident that with the current government safeguards, Willow will not significantly harm subsistence hunting because they didn't make that decision in a vacuum, he said. We were very much part of the process. The project also has the support of Alaska's political establishment, including Republican Governor Mike Dunleavy, the state legislature, and Alaska's bipartisan congressional delegation. So Graff and other environmentalists worry that the Willow project will lead to more oil development in the Arctic. However, what's her name? Deb Haaland, she took back all the leases. So I don't know. I don't think that's going to happen. So I'm going to go down just to the bottom. When the Willow project is moving ahead, the Biden administration has tried to temper the anger of climate activists by taking other steps. And that's what I was just saying, that this shows the other steps are Haaland canceling all these leases in the refuse. Okay. So, but then they still let this go on. The administration has proposed new rules that would limit future oil and gas development in other parts of the NPRA. It also reconsidered whether to allow drilling to the east in the Arctic National Wildlife Refuge and recently canceled oil and gas leases granted during the Trump administration. So that's what's happening out there in Alaska. They want to drill the North Slope. What do you think about that, Jennifer?
Yeah, give it a big old flush. I think that thing deserves a flush.
Maybe
don't
another
you?
flush. Yeah, we're going to give it another flush. Yeah. There it goes. But there's nothing we can do. And now now we need to be energy independent because we need to fund the military industrial complex. Oh, I had
There
to throw
you
that
go.
in. There you go.
It's a vicious cycle.
Yeah. So, guys, I want to thank, first of all, I want to do super chats. I want to thank you guys. There's 5 of them. And Dwayne, red hearts. Oh, he sent me red hearts of differing sizes. Thank you, Dwayne. And hit the like button. And that was lovely, $5. And Canal Frump, $20. Wow, thank you. Oh, my God. We are so fucked, but with graphs. Greetings from Singapore. WASF with graphs, Jennifer. Game over.
God.
Game over, Dwayne says, written in a pixelated way. Well, we don't want to, we just bring you all the information. And Kristen, I wish I could give more honey. That's fine. Thank you. I'm grateful. I'm going to give you all an applause. It's beautiful. Thank you. It really does help a channel. I was telling Jennifer earlier all the things that go into this thing behind the scenes. She's so busy all week. I don't bug her with it. I respect her. I don't want to make her stress out. No. And there were a couple of little favorites, but let me see. Oh, Paul. Hi, Paul. He said, love the ice cores. They show temperature changes at higher rates than now and higher temps. Yep. And Poppy. I hope Greta doesn't feel she failed the world. The world failed her. The world failed her. That's tough. Here's one for you, Jen. Not sure from obsolete. Not sure why they keep calling 1850 to 1900 pre-industrial when the Industrial Revolution began in the 1700s and England was burning coal as far back as 1170.
Yeah, there you go. They keep shifting that Industrial Revolution further and further along,
Telling you. Yep. I'm
Agree
telling
with
you.
you.
All right. Well, listen, guys, I'm going to give it to Jennifer to say the good night. And there's so many of you. Johnny, Too Late TV, thank you. And by the way, I interviewed Dr. Gilbs, and I have to decide if that's going up on Sunday or Tuesday. I think it's going up on Sunday, the Antarctic polar scientist from the UK. And that's done. And after this show, I think Letterhack is on live if you're looking for something that's not going to make you miserable. And I think it's a call-in show. Yeah. Oh, wait. Poppy sent me something. Thank you. Fan character with eyes wide open, blushing. Poppy, you're
Very
beautiful.
nice.
She's beautiful. She's beautiful. Thank you,
Thank you,
sweetheart.
Poppy.
And everybody. And if I missed anybody, it's because I'm brand new at all this stuff and I don't know much about it. Thank you for coming. Jen, Wrap it up,
Yeah.
baby.
Well,
Wrap it up.
it's been another methane show here at Environmental Coffee House tonight, and it's always good to catch up on it. It is a miserable subject to dive on into, but it's very, very important, and we can see what is happening to our world in this time of escalating methane emissions. So more heat is on the way. You can be sure of that. And we will see you next week.
Yep, we will. Thank you, everybody. I can't say thank you enough. Thank you. Love you.